Okay, here's some more problems from section 9.2, and this is number 39. And number 39 is a multiple choice, and it tells you f of 0, f prime of 0, f double prime of 0, and f triple prime of 0. And they want to come up with a third Taylor polynomial generated by f of x at x equals 0, so they give you the functions of the derivatives. So just put this in Taylor's formula, piece of 3 equals 0. Well, this is the Taylor's formula right here. Wrote it down. F of 0, x to the 0 over 0 factorial. F prime of 0, f prime of 0, x to the first, 1 factorial. Second derivative, 2 factorial. Third derivative, 3 factorial. So you write this down as much as you can to help you get this down. And they told you that f of 0 was 0, f prime of 0 was 1, f double prime of 0 was 0, f triple prime of 0 was 2. So these 0 terms that cancel off, so you just have 1 times x over 1 factorial, is just 1 times x, and then 2 over 3 factorial, which is 2 over 6, is just 1 over 3, or x to the third over 3, and I think it was just in reversed order, but it's basically this x plus x cubed over 3, and that was letter E. Okay, on number 40, which of the following is the coefficient of x to the fourth in the Maclaurin series generated by the cosine of 3x? Okay, so this is the cosine of x, 1 negative x squared over 2 factorial plus x to the fourth over 4 factorial. So it's real easy to get the Maclaurins for 3x. Every time I see an x, I just put a 3x. I put a 3x there. I put a 3x there and 3x there. So as you see, we can usually bracket that if we want in a nice color so you can see how that works. So there you go. So every time I see an x, I just put a 3x, and we have the same interval convergence, so that works fine. And then I can simplify this out, and I'm interested in the coefficient of the x to the fourth. So here's the x to the fourth over here. So that's going to be 3 to the fourth over 4 factorial. And 3 to the fourth, 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's just going to be 81 over 24. So this is what we're interested in, this coefficient. So 81 over 24, I can reduce that by 3. 3 goes in there 27 times, and 3 goes in there 8 times. So there was your letter A. Okay. On number 41. And 42 are kind of linked together. Here's 41. 41, which of the following is the fourth order Taylor polynomial generated by f of x at x equals pi over 2? So these are some nice multiple choice questions. You might see something like this on the AP exam. It's not, just to make sure you understand what these are. How to do these Taylor series. So, which is for, remember it tells you up at the top, exercises 41 and 42, let f of x be sine of x. So if I want the fourth order, I have to take the first 4 derivatives. So f of x is sine of x, f prime of x is cosine, f double prime negative sine, triple prime negative cosine. Fourth derivative is sine of x, and then I evaluate each of these at pi over 2 because that's my center. So f of pi over 2, sine of pi over 2 is 1, cosine of pi over 2 is 0, negative sine of pi over 2 is negative 1, and then cosine of negative cosine of pi over 2 is 0, and then back to 1. So I'm skipping the middle terms. So I've got, if I go back and look at my series from up above, except it's centered over here, I've got f of pi over 4, and then times x minus, pi over 2, f of pi over 2, times x minus pi over 2 to the 0 over 0 factorial, so that's just 1. And then my second term was 0, then my third term is going to be negative 1, and that's going to be x minus pi over 2 to the second over 2 factorial. Okay, and then this is going to be plus 1, so I'm going to skip so I'm skipping the first power and the third power, and my last one will be the fourth power, and that'll be positive because I got a 0 here on the third power, and this will be the fourth power, so I've got 1 x minus pi over 4 to the fourth. You see that 4 matches that derivative, all over 4 factorial. So that was my expansion. That was my fourth order. Okay, because we took 4 derivatives. but a couple of them zeroed out. So I only have 3 terms, but that's not significant. It's the number of derivatives and it's 4 derivatives. All right? And if we look at that, that matches up to the letter C on number 41. Okay? At least it looks like C to me. I just have the ones there. They don't have the ones. Okay? And then 42, which of the following is the Taylor series generated by f at x equals pi over 2? So we have to get a summation. Now, all the summations had n equals 0 to infinity. So if you look at A, B, C, D, and E, they all had that, so you have to match that up. Well, what I did was I made n. I showed this would be my n equals 0, n equals 1, n equals 2. Remember, I'm told that I have to start at 0. So if this is 0, that would be 1, that would be 2. So I tried to match these up. And it looked like I had alternating signs, so we're going to use the negative 1 to the n power, and that's going to work because negative 1 to the 0 is positive 1, negative 1 to the first power, because that's n, this is the n, it's going to be negative 1, and squared to be positive 1. So that makes the signs work. And if I look at this, this would be n equals 0, so I've got x minus pi over 2 to the 0, and this is going to be 1, so that's going to be double that, so that's going to be 2n. If I try 2n, that's going to work. And if I look at that, when n is 2, that's going to be 4, so that looks like that's matching up to n. And the same thing on the bottom, it looks like I've got 0 factorial. Well, that's easy. That could be 2 times 0. 2 times 1 is 2 factorial. 2 times 2 is 4 factorial. So it looks like this is the one that's going to work. And the key is to write down this n is 0, n is 1, n is 2, and you know from the possibilities, all 5 possibilities had n equals 0. So that made it a little bit easier. So the answer was letter A. Okay? That's 42. I hope that helps.